So Rutherford did gold foil experiment, and then he find out what's in that tiny atom. So you can see there is a circular fluorescent screen he took, alright, and in there he put little one atomic layer of gold foil, just a foil, it's just one atomic layer of gold foil. What is one atomic? Just in there, just one single atomic layer, not more than that. That's the gold foil, he took it, okay. Then what he did, he had, this is a kind of box, lead box. Inside he put source of alpha particles. So I am going to draw the source of alpha particles, and there is a little hole in here in the lead box. So this is a lead box, and this is a radioactive substance, so source of alpha particle. Okay, so this one, source of alpha particles, it's like producing alpha rays, okay, and that can go through here, so it has only chance to escape from here, alright, from this little hole. You can see the hole in that box. All others are confined, they cannot go through this box, but it can go out from here. Those alpha particles is bombarded on this gold foil. So he said, okay, I'm going to bombard on this gold foil, and this screen, this fluorescent screen, I'm going to write, this is a circular fluorescent screen. And he wants to detect how these rays behave, alright. And alpha particles means positive charge particles. So we have positive charge particles. It's bombarded on this gold foil. So what he sees? Most of the rays, they just go fast through it, right? But some of the rays, they bounce back. And he said, whoa, let me see why these rays are bouncing back. Okay, so let's see. I'm going to draw this micro level of this gold foil and his rays in a next slide. He said why these rays are bouncing back. Okay, so I'm going to draw to next slide. So he said, okay, this is a gold foil, single layer gold foil, okay, and these are centers, okay. What he said, most of the rays pass through, right, because what happened, it just atoms, they think they are empty, so they just pass through. But some of those, alright, some of those alpha particles, positive charge particles, they hit to the core of the center and they bounce back, right? And then he said, okay, atoms, most of the space when they go straight, it's empty, but there is some core, center in the atom. That's make this bouncing back, reflecting back those rays. Alright? So, let's talk about that. So, he said, he proposed. Now I'm going to write what he proposed based on his observation. Okay? So, you know that, right? It's bouncing back, and that's at micro level how it behaves. Alright? So, what he proposed, alpha particles pass through the foil because an atom is largely empty space. But at the center of an atom is the atomic nucleus, which contains atoms' protons. Okay, and so the alpha particles that bounce backward did so after striking the dense nucleus. So he discovered new model of the atom. So what is his proposed model? He said, yes, in the nucleus there is a center nucleus and there is a whole empty space. In that nucleus you can see electrons, and in this nucleus protons and neutrons. He said this is his new model, Rutherford's model of atom. He said negatively charged electrons. These electrons are negatively charged. And it's distributed around positively charged nucleus. And so that's his new model. Before that everybody followed Thomson model, but then Rutherford found this new model of the atom using gold foil